Hi.
Hi, Katie. How are you?
Good, how are you? Sorry I was a little late.
It's okay. Things happen. Life happens.
My brother was like, I'll be out by 3:45. I was like, okay. And he got out at 4:30.
What grade is he in?
He's a senior.
Oh, okay. Hi. Did you do any questions in the school?
Yeah, I did. I did a bunch of them.
Okay.
Hold on, let me just get my paper. For the blue, oh, it's not blue for you. We got it blue. For the performance task, the actual homework, I did like one all of question one, so like up to 1F.
Okay. Okay.
And then I did question one and two for the playing cards. Or one, two, and three for the playing cards.
Okay. Okay. Not the instrument one?
No.
Okay.
That one I don't understand it.
Okay. Let's see. Mhm.
And then I also started the practice test.
Is it everything that you sent me?
Yeah.
Or is there more? Okay. Let's see. Mhm. This is your question too. Okay, what's happening here? Can you see the question? Okay.
Yeah. Now I can.
Okay. Different collections of instruments from a set of 24 guitars, 42 flutes. You'll just see it here on my phone. It's just too small for me. Okay. Okay. I can't select the pen. Let me select the pen. There you go. Okay.
Okay. Collection of instruments, 24 guitars, 42 flutes, 19 violins, trumpets, drums. Find the following probabilities and leave answers as NCR.
Okay, so collection of 27 instruments has 11 flutes. So you're collecting it for the first part, you're collecting a total of 27 instruments. So I'm finding the probability P of the whole thing. So it's going to be something over the whole thing. So you
Mm-hmm.
have 113 instruments, and order does not matter here. So that's 113 C27. And then you have 11 flutes from how many flutes you have? 42. So that's 42 C11. Or really, 113 C27. That's it.
Okay.
But are you selecting more? Let me see. Wait. 42, a collection of 27 has 11 flutes. Okay. Oh, there's just collecting 27. So you've already collected 11 flutes. The remaining would be 27 minus 11. That's 16. So you need to select 16 more from the remaining 100.
So you do 42 or you do 113 or 113 minus 11 C
Yes. 100,
16.
113. So basically you subtract the NN and the RR. That's what's remaining. Right. So now you've already selected 42 from 113, so the remaining is going to be 113 minus 42. That's
Well,
71.
wouldn't you just subtract the 11?
11, you've already selected 11 from what? 42, but you still need a couple of more. Like from 27, you've only selected 11, so you need 27 minus 11. So that's
Yeah.
16 more. So 16 from 71
And the 71 is 113
minus
minus.
42. Yeah. So basically you subtract NN and then RR and CR. That's how you write it, right?
Wouldn't you just subtract 11 from 113 though and not 42?
11 I subtracted from 27 because you're selecting a total of 27 instruments. From among those 27, you've selected 11. So how many do you need more? That's going to be 27 minus 11, so 16.
Okay.
Okay, I'll go again. So you're to select a total of 27 instruments from 113, so that's going to be a denominator. Now, from those 27, you have 11 flutes. 11 from what? From 42. So that's 42 C11 times you still have 27 minus 11 remaining to select. So C16, that you need to select from what? From the remaining that's remaining, that from the 42 that's still remaining. So it's 113 minus 42, that's 71.
Why wouldn't you do like from the remaining of the total instruments and like you're why I don't understand why you're subtracting all of the flutes and not just the flutes that you picked out.
Oh, okay. Because according to you, you still have like some of the flutes remaining.
Yeah.
Because if you do that, let's see you do that. So 42 minus 11, so that's going to be 33. So you still have 33 flutes left. But if you pick 16 from 33, you might end up getting some flutes as well, but you only need 11 flutes. And we're already done selecting 11 flutes.
Okay, so you can only have 11 flutes.
Yes.
Okay, okay, okay.
Okay. So that's 42 to 11, and then you subtract the whole thing because we don't need any more flutes now. So you get rid of all the flutes now.
I
Like,
see, I see.
okay, that's the first part. Hmm. It's the second one. Collection, if you want to try the second one, try to.
Yeah.
That's 4 guitars.
So you do the same like a 113 C27.
Oh, you just
Or not
post
27.
51 now.
Yeah.
Mm-hmm.
And
Okay.
then four guitars.
Mm-hmm.
So
Okay.
and then five drums.
Mm-hmm.
And then from the 51, would you subtract the 24 and 13?
Let me see here. Momo has 4 guitars and 5 drums. Yes.
Okay. So it would be,
What is
and then do 113 minus,
minus 24 minus 13?
yeah, like that.
76, that's correct. But then where did you get this 14? You've
The
already.
fifth, oh, I did 51 minus 24 minus 13. So you do 51 minus 4 minus 5.
Yes, yes. Basically, you subtract n together and the r thing together.
Okay.
Sorry. So yeah, that's right.
39, 16 stringed instruments. So that's just violins and guitars.
Yes.
So it's 43.
16, okay. Mm.
And then,
Yeah, you have 39. The denominator keeps changing. The number of instruments keep changing in all the options.
yeah, 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 I always forget.
Mm.
Uh-oh. And then 16 strings. So you do 16 minus 39.
Yeah,
Or
39.
39 minus 16.
Yes. Okay. Yeah,
Like
that's right.
that?
Yes.
Okay. At least 16 violins. So this time
Oh.
you would do like what I was asking up here.
Yeah.
Okay.
So,
How many violins are there? There's 19.
19, okay.
Then would you do 19 minus
Mm.
1, or you do 16 minus 113 and then 25
So
minus
there's going to be
113?
multiple cases now. So you have at least 16. So you pick at least 16 and then times the remaining, which is what you said. So that's what? C 25 minus 16. It's 9. And then 113 minus 19. 9,
But
9.
if it's at least
Yeah.
16, wouldn't you do 113 minus 16?
You don't subtract the n and the r. It doesn't make any sense. You're subtracting r. You've already picked 16 instruments, 16 violins, and then you're supposed to pick 25 instruments. So the remaining is 25 minus 16, not 113 minus 16. So therefore you have 9. That's the r value that's getting subtracted. From what? From the remaining 113 minus 19, the n value that's getting subtracted is 94. That's one case where you're selecting 16 violins plus you're gonna have three more cases. So it's 19. From among those 19 violins, now you're selecting 17 violins. So that's 19C17 times, and then you still have how many more? 17. So that's C. 25 minus 17. So that's 8 more left. From what? From 113 minus 19. That's 94 again. Did you get it? Consider
Yeah.
all the cases. So you're picking 16 violins, 17 violins, and there's going to be one more 18, and the last case picking all of the violins.
Okay, okay. So then this would be
19C18. Oh, yes.
and
Time.
then so it gets a little bigger. Times 7.
Mm-hmm. Now because you've selected the 18, so the remaining is 25 minus 18, 7. Okay.
Yeah. And then
All of them are valid. Uh-huh.
or it'd be
Six.
6.
6. Yes. Are you supposed to simplify the answer, or you can just leave it like that?
He says leave it in NCR.
Okay. So that's it. That's your answer.
Okay.
You cannot subtract the n and the r values. One of the options you said, why don't you subtract like 16 from 113? R by r, and I mean that's how you write the permutation combination NCR. So from among a total of n that you've already picked something, you need to subtract the n values. If you have like 100 of them and 5 of them are already used, so you need to do 100 minus 5. That would be your n value. So now you're picking from those 95C, whatever you need.
Would you do it for permutations though?
Yes. So you
Okay, that's what I was thinking of.
okay. Third question?
Um,
What is it?
yeah. I started 1 and 2 for the cards, the playing cards one.
Okay, what's happening here? May I?
May I Sing is an opera singer.
Oh, that's the name.
That's
Okay.
her name. My
Okay.
teacher always does that. He does like You Will Fail, or his name is Mr. Wong, so he'll do
Oh, okay.
like Mr. WO and then Mr. NG.
Okay, I thought that she was trying to take a permission for something. May I? And then, okay.
No, he's like weird like that.
A voice will be known to shatter glass when it hits the note. The probability that a voice will shatter. Okay, so let's pick a variable. You can pick any. So let's say it shatters the glass. That's how I like to approach the problem. Write anything that's given to us in the question mathematically. So probability of her shattering the glass, let's say probability S, shatter, that's 0.35. So probability of her not shattering. So there's two
Is
ways to,
1 minus that.
yeah. So either you write it as S complement or you put a bar on top. They both mean the same thing. It's like not
Yeah.
negation of something. Yeah. 0.65.
So 6-5.
Okay. For the next part, what do you think should we do?
Let X the number of shattered cups and P of X, the probability of shattering. Let X equal the number of shattered cups and P of X equal the probability of shattering exactly X cups. Calculate P of 0, 1, 2, 3, 4, and 5. Is this what we did yesterday?
Yes, because the X value keeps on changing. The number of event is still the same. You shatter the class, but how many you need to come up with that table. So probability distribution. That's what you're supposed to do.
Okay. So is it that big like X and then P of X table?
Yes, and that's how you figure out if X keeps changing. And you're supposed to find the probability of each of those X's. It's the table, the probability distribution table.
So where do you find like the equation then?
That is where you use the formula in the PX table. Do you remember the formula, the permutation formula?
It's like
The AB.
NCR A to the N, B to the N
Yes.
minus 1, or 1
Yes.
minus N.
Mhm. So
How do you find the
A
all
and
the
B. Oh,
variables
the
then?
A and oh, okay. N is a total of thing. There's how many glasses? So there's a total of 9 glasses. So that's N. So 9C, and then the R keeps on changing. That's your X value. So 9C, 0, how many? You're breaking 0 cups from those 9. You're breaking 1 cup from those 9. So that's 9C1, and then
Okay.
and
And
A
then
and
point
B.
three. Okay, point three is the A, and then
Yes.
0.65 is the B.
Mm-hmm.
Okay.
Yes.
9, right?
Mm-hmm.
Or would you do 5 or 9?
No, 9 minus 0. That's it.
Okay.
This 5, 1, 2, 3, 4, 5 represents the R value, the numbers that you're writing at the subscript below. Right.
We're only finding for 5 cups, right?
Yes.
Okay. That's 5.
Oh, that's right. Yes.
And then round
If
each column. Okay.
if this question was randomly given to you, would you know what to find?
I think now, yeah.
Okay. So again, your X would keep on changing, and the question would be to find the probability of those different X's, not just one X. If it was
Yeah.
just find the probability of one, you would just use a combination formula for just one. But if it's a table, it's a probability distribution table.
Okay. Let me get my graphing calculator out. Ugh, I hate typing all this in.
Up to 2 decimal places. Okay. What was the next number? 0.021?
It was 07. Or
0.02.
then you do just 20.
For the first part, was it 0.021 or 7?
It was 207.
207. Oh, okay. So then it's 0.021. Up to 2 decimal places would be just 0.02. Okay. Calculator. This is the combination of this. And there's a reason he didn't tell you to find the probability for all of the values. You'll get that in the next question.
What is the probability of shattering at least 4 cups?
Mm-hmm.
Is that this one?
At least four. So it's going to be 4, 5, 6, 7, 8, 9. So then would you find the probability for 6, 7, 8, 9 again? And then add all of them up?
No, it doesn't. Wouldn't like doesn't this whole thing equal 1? So you could just do 1 minus all of
Not the
these.
whole thing. If you had found the probability until I mean, for all of those 9 cups, then it would have been 1. But you
Yeah,
only found till 5. So for the next part, would you find the probability for 6, 7, 8, 9 too?
you could, but you could just subtract 1 minus
The
these.
Yes, exactly. Yeah, that was the whole point of only finding till 5. Yeah,
Or yeah, 0.36.
that's the answer, or is that the sum of the first three?
That's 1 minus the first three.
Okay, okay. You have the answer. I'm guessing it's the same thing. Let's see. Mhm. 0.65, 0.39. That's 0.02, 0.1, 0.22. Oh, this right here is your error. Because of this, your option C, answer C would be incorrect. It says up to 2 decimal places. You only put 1.
But it rounds up to
But you still need to put 2 decimal places. Round it up to 2 decimal places. What did you get for 9C3? This is right, this is right.
um
Just because of 1 point, your answer C is a little off from the original answer. Should be 0.2 something.
I can't go back. Hold on, let me
Okay.
I have like the old crusty calculator from
Uh,
school. It's like a gabillion years old. 9C3.
9C3, 0.35 cube, 0.65 raised to power 6.
0.27.
Yes, so that should be your answer. Now you add them up and then subtract from 1 and you should get, what is it? What's the answer is 0.39.
Oh, okay.
Okay, so if it says 2 decimal places, after decimal, you should have 2 places after rounding it off. If it was 0.272, it would just be 0.27. If it was 0.276, then this would be 0.27. So up to the 2 decimal places, meaning after decimal, you need to have 2 places.
If it was 0.279, does this not round up
0.28.
to 8?
Yes, 0.28.
Okay. Oops.
Okay, but you cannot round this up to 0.3. If the question was to round it to 1 decimal place, then this would have been correct. So just
Okay.
one point, not rounding it off to a correct decimal place, your answer C would have been incorrect. So make sure you do that.
Okay.
Okay, question 4. What's the fourth question? Oh my God. So this one? Oh, that's 5. Oh, this is 4. The ABC company. Okay.
Or can we do the cards one?
Oh, the one with the diagram?
Yeah.
Okay.
The one for it's just the homework assignment.
This one, question 6.
I think that one's the practice test. And then
Okay, is there anything? Because I don't see any other card question. Which one is it?
it was the second assignment I sent you.
Oh, I don't have anything else here.
Wait, click on that one again. Does it say, is the first question?
That's the 6 letter, 8 letter arrangement thing. A regulation question.
Go to the one to the first one.
Yeah, this is binomial.
Like the top right, the top left corner.
That's the card one with the diagram.
What's the first question?
Face cards are jacks, queens, and kings, starting from a full deck of cards that are randomly arranged.
Oh,
Present.
that's the practice test.
Oh, I didn't think. Maybe you have something else, but you didn't send it. Let me see.
The other assignment, the second one I sent you.
Mhm.
I sent you the practice test and then the actual homework.
Oh, okay. There's two documents. Mm, choosing a program is binomial, and then you have this. I don't see any other question. Can you send it to me again, please?
Yeah.
Mm. Hmm.
Maybe I missed it. Oh, I don't know where it went then.
For who?
Hold on, let me find it real quick.
Sure. Management.
Oh yeah, he linked it on a different assignment.
Oh, okay.
Okay, yeah, I'll send it right now. Sorry, I didn't even like see that.
It's okay.
I did 1 and 2, or 1, 2, and then I think I did 3 wrong.
What is the probability that both cards of these questions? You did 1, 2?
Yeah, I did 1 and 2. So like the deck is shuffled and a card is random selection. I did that, and then I did the what is the probability that both cards are a diamond?
Okay. Let me paste the problem. Oh my God. Let me just. Okay. Okay, so you did 1, 2, and the third one, number. Can't see the whole thing.
Here, go to the next picture. Yes, yeah.
Okay. Numbered cards are the cards having a number between 2 and 10. Let me paste the problem here. Still have. Starting from a full deck of cards that's randomly shuffled, what is the probability that the random card selected is a club or a multiple of 3? I always have to think for these card problems. Can't remember how many cards are there. It's a normal 52 deck cards thing, right?
Yeah.
Nothing different about it. Okay.
The diagram has all the cards on it.
Okay. Let's
So
see.
there's 13 clubs and then 8 multiples of 3, including the clubs.
Okay. Between 2 and 10 selectable. Random card is a club or a multiple of 3. Okay. So you have total number of clubs. You said 13, right? Yeah, 13. So
Hmm.
probability of selecting a club is 13 over 52. What's the probability of selecting a multiple of 3? Multiple.
8 over 52.
3, 6, 9. That's 3. And then 4 of those, right?
Oh, I forgot sixes. Did I? Yeah, I did. So there's 12.
Yes. So 12 over 52. And now the question is to find this word here is important. Is a club or a multiple of 3? So you're finding P, A, or B, or A union C, same thing. P, A, or B. In this case, you're picking club or a multiple of 3. I'm just using a different variable. You can choose whatever you want. So that's 13 over 52 plus 12 over 52 minus the one that you've counted in both of them.
Which is 3.
3, yes. So 3 over 52. 9, it's about 22 over 52.
I wasn't sure what to do because I was like, oh, they intersect. And then,
Yeah. So if you have an intersection, if it says or, so you're supposed to find A or B, meaning A union B. So you need to subtract the intersection part if there is any.
Yeah.
meaning subtract the common thing. If the question was to find the probability if you're selecting a club and a multiple of three, so it would just be 3 over 52.
It would, oh, okay. Yeah.
Okay? Like it both have them. Oh, no, it could mean two different things. And meaning you take this, and if they're independent, you multiply. But yes, if it's like common to both, it would just be the intersection part, which is 3 over 52.
Mm.
Okay, what's happening in the next part? When playing a card game, you're given 6 random cards. Okay. For a full deck of 52. What is the probability of getting 2 cards of the same rank? What's the rank? Oh, it's the if you
It's
select
like
once, it's
1, 2, 3, 4, 5,
one.
6, 7, 8, 10.
Okay. It looks like you play cards a lot. Do you?
I don't. I He was just like, he always rants about that. He's like, each card has a rank and everything has a
Oh,
number and the suits. And he's like, if you guys don't know this on the test, like
yeah.
you're gonna fail. And I was like, okay, that's awesome.
Okay, so you're selecting, at least find the denominators. Suppose to find the probability, and you're selecting 6 random cards, so that's going to be 52C6. Now let's find the numerator. 2 cards of the same rank. So how many possible ranks are there? Like ace,
Um,
10, and then jack, king, queen, 13?
yeah.
Okay.
Let me check real quick. Yeah, there are 13 ranked cards in each suit.
Okay, so 13C1, we're picking one of the cards from those 13 rank, and then 2 of them have to be of the same rank. So that's just one possibility. You should either select just like one, so the other one is just gonna be one. This
What is the probability of getting 2 cards of the same rank, 3 cards of a
and then 3 cards,
different same rank of a different suit and same rank? Is that what it means?
3 cards, 2 cards of the same rank. So if you
There's so
selected
many words.
A's, yeah, that's what I'm trying to figure out too. So let's say if you selected one, so the other card is gonna be one again. 2 cards of the same rank, and then 3 cards.
Of a different same rank? Oh, so it's like just a different,
Oh, okay, so let's two, so then two, two, two.
yeah.
Okay. Okay. And then 1 card of different rank, then the other two chosen. So let's see, 3. Okay. Okay, I think I'm getting. Okay, so
So
third
it's probably, what is it probably 2 cards of the same rank? So thir it would be 13C2 or
13C1.
13, would it be
Picking a
13P?
the order doesn't matter in this case, right? No.
Uh,
You just
or no,
select.
it doesn't. Yeah.
No, it doesn't. So from those 13, you've picked one, and then you need one more from the same rank, but you've already chosen one, so the remaining would be 12, and then you're picking one again from those 12. So that's 12C1, right? Times, and then for 3 cards of a different same rank.
It would be everything minus the 13 and 12.
11
C2.
C1 again. Oh my God, this is so confusing. Let's see.
For the first one, if you're doing it like,
If you're thinking 13C2 for the first one, it could be from those 13 ranks, you're picking either one rank or two, like two numbers. You get what I mean, right? Like one or two. That's what 13C2 would mean. 13C1 meaning you're fixing one of those things. It could be the one and two, and then you need one more from the same rank. So you cannot
oh,
13C2.
okay. So the 13C1 times the
12.
13C1 is just the
12.
one
Yes.
thing.
Yes, one thing from like one rank.
Or 12, is the second one 12C1
12,
or
yeah, 12,
okay.
because you've already, yeah, it's 12
So it's
remaining.
13C1, 12C1, and that's like just the first one.
Yes. Mm-hmm.
And then you do 11, or for that, so that's the 2 cards of the same rank. Then the 3 cards of the same rank, you do 11C1, 11, or 10C1,
Yeah.
9C1.
C1, yes. Oh my God. I don't even know if the answer matches. Okay, we can check it later.
So 11C1, 10C1, 9C1. And that's the
Four.
second one. Or like the 3 cards of a different same rank. Or how does that ensure it's a different same rank though?
Yeah, that's what I'm thinking too. The words are really confusing. Try the next one. I'm just thinking. I
And
need a
then
second.
one card of a different from the other two chosen ranks.
Oh,
Wow.
come to your question, how does it ensure it's a different rank? Because that's why you're subtracting the denominator and sorry, the n values. So you've already kept them separate, so there's no way you can pick from those cards again. But
Oh,
still very confusing though. Hmm. Um, Plain paper. Okay, let me write this down. So you have two cards with the same rank. That's 50.
oh, I think it's you do 13 and then 12. So the first one would be 13 C1, 12 C1. And then
Mm-hmm.
since you're choosing it from a different rank, you'd start again with 13.
Then you could get,
Yeah,
oh,
like if you
yeah,
go to the bit
13
paper,
cards.
I'll show you, I think.
Yeah, 14 C1 times, and then,
And so this is just the first one. And since you're picking from a different rank,
uh-huh.
you're not picking from this 13 again.
Yes, yes.
So you just do 13 C1 again.
Or I needed to see the diagram. Maybe that would help. Let's see. Where is the diagram? Because, okay, I think I might have it now.
And then you do the 13
Diagram is
again.
still the same. It's so let's say you pick these are all ranks, right? Like 111, all these are the ranks.
Yes.
Okay. So let's say you're picking one of the ranks from those 13 ranks, either one, two, king, queen, whatever. So that's gonna be 13C1. And now let's say you fix one of them. Pick any. Let's say five. This one. So now this gets fixed. So now you're not picking from for the second of the same rank. Now you're not picking from all of the 13. Now you're picking from those four. So now that should be four. And since you've already picked three, so this should be C3.
Oh. Okay.
Okay. Times, this was one of the cases and then for the third, what was the second case? You're picking,
Well, if wouldn't you start with 4 then instead of 13?
if you pick like you're already fixing this. No, you need to fix this using the ranks that's from the total ranks, which is 13. From among those 13,
Oh,
you're
from
fixing.
the
Yeah,
okay.
it's from the whole thing. Yeah. This diagram, yeah, thanks for the diagram. That makes it a little easier. Now, from those 13, you've already picked the rank, let's say 5. So now you need to pick any other rank other than the 5. So you have 12 more remaining. So now from those 12, selecting one again. So let's say now the next one is going to be 2. So there's going to be 12C1. Now you're picking the rank, which you picked out to be 2. And then again, it's fixed now. So that's going to be 4C. What is it? The same color or rank was one or two? How many are you selecting?
2.
Two?
It's 2 cards of the same rank, then 3 cards of a different rank.
Two cards of the same rank, then three cards of a different rank. So you selected one, so you need two more. So 4C2. Oh my God. Did you get
Wow. Yes.
it?
Yeah.
Okay. And times, what was the third statement? Like
1 card of a different rank.
one card of a different rank. So 13C1,
Like
12.
different from both of them.
Okay, so that's the next one is going to be 11C1 times, and then again you're fixing, let's say whatever this one, and you just need one, so that should be 4C1. Okay, yeah, I'm pretty sure this is right now.
Okay.
Did you get it though?
I think yeah.
Okay, so you're fixing a rank first, and then the second card that you're selecting after you fix the rank, it's going to be from those four cards because now
From
it's
the
all,
4 cards in the rank.
yes.
And then then it goes down to 12 because you already chose that rank. Then it goes down to
Uh-huh.
11 because you already
Yes.
chose those 2 ranks.
Uh-huh.
Okay. That was
Yeah.
weird.
Yes. And then whatever the denominator was 52 6 C6. You're selecting a total of six cards. That's a probability.
Yeah. Okay, so it would just, yeah, 13C1, 4C3.
Three, yes, because you're picking four cards.
Yeah, three card. Or you're picking two cards to start. So 4C2.
Oh, for the first one, this is going to be 4. So because 13C1, you've already picked a row and a card from that. Now for the second one, you're ensuring it's from the same rank. So 4C, and then how many are remaining that you need to pick?
Two.
Twos. So a total of two, right? So
Yeah,
then this.
4C2.
Why am I confused again? 4C.
You're picking two cards of the same rank to start.
Two cards of the same rank. So you've already picked one. And then from among those four, so two, yes.
Okay, then you do 12C1, 4C3,
Mm-hmm.
and then you do 11C1, 4C1.
Mm-hmm. Yes.
Okay. Okay.
Or 52C6. That's one
Yeah,
card.
yeah, yeah. Over 52C6.
Oh, okay.
That's so many words,
Yeah.
so many ranks and
Yeah.
cards.
It's been some time. I didn't even know what a rank was. I kind of forgotten. Okay, so if you have a question like these, maybe refer to the diagram. That would make things easier. So if you're
Yeah,
selecting something, selecting a rank and then one of those cards from the rank, so you fix a rank first from 13, and then you keep on subtracting the ranks if you're selecting a different card for a different rank. And then simultaneously, from those four cards, you pick however many you need.
yes.
Okay, that was question 4.
Is it 52C6 because in total you're picking six
6,
cards?
yes. From 52, yes.
Okay, okay. And then number 5.
Okay.
When playing another card game, you're given 7 random cards from a full deck of six for 52. So underneath you do 52C7.
What's going on? Okay, yes.
What is the probability of getting three? Oh my God, it's this again. 3 cards of the same rank, two
Oh,
cards of a different same rank, and then 2 cards of a different rank. Okay, so then you just do the same thing where it's like 13C1, 4C3, then 12C1,
mm-hmm.
4C2,
Yes.
and then 11C1, 4C2 again.
Two cards of a different rank. Yes. Good, yes.
Okay, let me write that. So you do 13C1,
Three cards.
4C2,
Mm-hmm.
then 13 or 12C1,
You need
4C2, or three. So you start. Oh, never mind.
four,
It'd be 4C3 to start.
three, yes.
3, 2, 2, and then 11C1, 4C2.
Two cards of 11C1. What did you say the last one was? How many cards are you picking? It's 2.
11C1 and then 4C2
Uh-huh. Yes.
over 52C7.
Mm-hmm.
Wow.
Okay.
Okay. And then that's all of the first packet.
Okay. What about this one? The
That
others?
one I haven't done yet.
Okay.
That's the practice test.
Okay. Did I paste the fourth question here? Not yet. Okay. Paste
I
that.
did number 1, A, B, C, D, E, and then I haven't started number 2.
Oh,
I
yeah.
it looks like it's just this
The 2 is
thing.
the instrument problem.
Yeah.
Okay, we just did that.
Is it the same numbers?
No, different numbers.
Or 27, 11,
Oh,
51, 4, 39, 16, 25, 16. It's the same numbers.
we did this. Okay, I'm kind of mixed up on what is your practice sheet and what is the other one. Just whatever you sent me, just I think they kind of mixed up now.
Yeah, sorry.
It's okay. Uh,
The first chunk of pictures I sent you is
uh,
the practice test.
okay.
Then the second one I sent you at the same like time is the homework assignment,
Okay.
which are they're separate. And
Okay.
then the very last one I sent you like during the call is part of the homework assignment.
Okay. Did you do this one? The fourth question? Again, I don't know what this is from. I think practice one. It's the choosing a
I
cell.
haven't. That was from the practice test.
Okay. So this is choosing a cell phone problem.
It's easier to tell them apart because he gives us the paper different colors.
Oh, okay.
So I wish he like put it in the thing as different colors so you could see. Okay. You're choosing a cell phone company to sign for the next 2 years. Three plans you consider equally priced. You ask several of your neighbors whether they are satisfied with their current cell phone company. The table shows the joint relative frequencies. Okay. Company A, use the above two-way table. Which cell phone company should you choose? Support your answer by finding the appropriate conditional probabilities. Well, company B has the most satisfied and the most
Yeah, you need
unsatisfied.
to now you need to think of it as a whole. I mean, it's a conditional probability. That's so that you say, what's the conditional probability? Somebody is satisfied given they're from a specific company. So probability of somebody being satisfied given they're from a particular company. So you need to find the whole thing first. That's going to be probability of S intersection C over probability of the company. So the denominator is the whole thing, satisfied plus not satisfied.
Okay, so for company A you do 0.24
Plus.
over 0.24 plus 0.09.
Yes. Yes. If at all you get confused, just use the formula, then you would know what goes in the numerator, what goes in the denominator.
Yeah.
So you're satisfied given you're using a company. So given that goes in the denominator. Yes. Okay.
And this one is 25 over 25 plus
Mm-hmm. Yeah.
0.11.
Mm-hmm.
Uh-oh. It always glitches. But it says point 694.
Okay.
And then the next one is 0.23 over 0.23 plus 0.08.
Mhm.
And that one's 0.74.
0.74. So this, but companies you have the highest probability. So select C. One thing, if I change the question to what is the probability of a customer being from a company using a certain company, maybe ABC, given they're satisfied, would it be the same thing?
Wouldn't you do like the company over the satisfied?
Yes, exactly. So then the denominator, the whole thing changes. So now this becomes probability company over satisfied. So the numerator would still be the same because that's the intersection part. C intersection S intersection C means the same thing. But it's the denominator that would change. So then the probability of satisfied would be you adding all of this up, 0.24, 0.25, 0.23.
Okay.
Okay, so be very careful of what's being asked. If it says given something has happened, so then that goes in the denominator. So you need to add the probability of that particular thing.
Yeah.
Okay, so you pick C.
Okay. Determine whether having a cell phone service with company C and being satisfied with the cell phone service are independent events.
Okay.
So isn't this it's P of A and then P of B given A?
If, what's the definition of two events being independent?
Like they don't affect each other, right?
That's just a layman definition. How do you find it in terms of probability? If I say A and B are two independent events, what can you tell me about the probability?
Uh
It's P of A and B equals
is
PA times PB if they're independent.
Okay.
So you need to check this. PA and B, I mean PS and C. If it's the same thing, a probability of S times probability of C. If they're equal, then they're independent. If not, they're not independent.
Okay. So company C being satisfied is 0.23. Or A is
And being
having a cell phone
satisfied. So
service with company
S and
C.
C. So S and C is 0.23. Okay. So now you need to find S separately and C separately. So probability of A, sorry, probability of satisfied. So all of this.
0.25 plus 0.24 plus
Mm-hmm.
0.23
Yes.
is 0.72.
Okay. And then times probability of B was what? Company C. So 0.23 plus 0.08.
0.31
Is the product equal?
times
Oh, the
0.72.
first part, let me do
So it's
S.
similar.
Oh, we didn't find S and C though. Did we? Oh, it is 0.23. Oh, it's the same. So almost similar. I think maybe some calculation. So they're equal, so they're independent events.
Yeah.
Yeah, that's it. So remember the definition of two events being independent. I mean,
Okay.
diagram wise and in layman terms, what you said is right. Independent means the Venn diagrams that would be separate, disjoint. But this is the mathematical definition of two events being independent.
Okay.
Okay. The fifth one is the binomial thing, I think.
Oh, I did this one.
Okay, good. And then
That one was fairly straightforward.
the sixth one is the same deck thing, the card.
I don't. I think that one's different questions though.
Yeah, these are two different questions.
Yeah. Okay. A standard deck of playing cards contains 52 cards. The cards are divided into four. Okay, that's just telling you what the cards are. Face cards are jacks. Or face cards are jacks, queens, and kings. Starting from a full deck of cards that are randomly shuffled, what is the probability that a random card selected is a spade or a
Or,
face card?
or.
Okay, so this one you do spades
Mm-hmm.
over 52
Okay.
plus face cards over 52 minus the intersection.
Yes.
So spades over 52 is 13 over 52
Mm-hmm.
plus the face card, which is 3, that's 12.
Mm-hmm.
12 over 52 minus the intersection, which is 3.
Yes.
13 plus 12 minus 3 is just 22, right?
Yeah.
And that's 11 over 52 divided by 26.
Yes.
Leave answer n as a reduced fraction. Okay. Okay. And then when playing cards, you are given 5 random cards from a full deck of 52. 4 of a kind is having 4 cards of the same rank and 1 card of a different rank. Wait, what? When playing cards, you're given 5 random cards from a full deck of 52.
So you're selecting 5 from 52, so that's going to be 52C5. And then from those 5, you're selecting 4 cards that's going to be from the same rank. So let's say you've selected 1 as the first rank. So it's going to be 13C1. And then from those 1 rank, all of those 4 cards are the same rank, meaning 1, 1, 1, 1. So then that's going to be 4C4
Okay, 4C4, and then you do 1
times
card of a different, and then you do 13, or you do 12C1.
1 card of a different rank.
You do 12C1 times 4C1.
Yes.
Okay. Over 52C5.
Yes.
Okay, and that's the last question, actually.
Okay. I did find something for you. Maybe it could be on the test because it's a very classic probability problem. It's called a handshake problem. There's nothing.
Uh-oh.
Have you heard of it? So you go to a party and then people they're shaking each other's hands. And let's say if you're fixing the number of people, six people are at a dinner party, which expression represents the total number of handshakes that happen at the party?
6 people meet at a dinner party. Each person shook hands once with everyone there. Was 6 factorial 2. Oh, 6 factorial. And will you do you could just do 6 factorial over.
Don't try to think this in terms of factorial. There's one step missing in between. You're supposed to use either permutation or combination, and then you get to the factorial answer.
Oh, 6 C6.
6C6. Everybody's shaking hand with everybody. How many people do you need to shake hands with at a time?
2.
Two, so 6C2. And that's how you get 6 factorial over 2 factorial times 6 minus 2. That's 4 factorial. So option D.
Okay.
It's a very classic handshake problem. If you have n number of people, it's going to be NC2. And there's one more question that I found.
So be number 4.
The option 4. Oh yeah, this one. Let me paste the problem here. It's a good one. Um, Just pasting it on the next page. Okay.
Okay. In my town, it's oh there. In my town, it's rainy 1/3 of the days. Given that it's rainy, there will be heavy traffic when the probability with probability 1/2. And given that it's not rainy, there will be heavy traffic with probability 1/4. If it's rainy and there is heavy traffic, I arrive late for work with probability 1/2. On the other hand, the probability of being late is
Are
reduced
you
by one.
processing all the information in one go? What's happening?
Kinda.
Okay. Go ahead.
1/8. If it's not raining, there's no heavy traffic. Okay. You pick a random day. What is the probability that it's not raining and there's heavy traffic and I'm not late? So it's rainy 1/3 of the days.
Hmm.
And then heavy traffic is 1/2 of the days. And then raining and not late is reduced. Wait, what?
Okay.
There's so many
Yeah, so many
things.
variables. That's a problem. So rainy is 1/3. So let's do our complement or whatever you use. Do you use this? R bar?
Yeah,
Not okay. So that's gonna be 2/3, not rainy. If there's traffic, that's half. So traffic, no traffic. So that's half again.
yeah.
Also, right, late for work is probability half. So she's late. That's half again.
Why is she late half the time? That's not good.
Oh, also you wrote down the probability incorrect. There will be heavy traffic. Oh, okay, okay, okay. There's so many conditions you have there. So that is why I gave you this in question. I mean, I wanted you to write down the information mathematically, but this clearly isn't the right way. Because for a rainy, you have a different probability for a traffic. And then if it's not raining, you have a different probability for the traffic. So where do you write it? And there comes your tree diagram. You remember
Oh,
the tree diagram?
the
So rainy and then not rainy, R bar. Okay. So this is going to be probably it's raining 1/3 of the days. So 1/3. Not raining, 2/3. Just a normal day. Okay. And then you keep on bisecting the whole thing. When it's raining, given it's rainy, so now you're supposed to bifurcate this thing. There will be a traffic with probability half. So let's say this is T, and that's half. So given it's rainy and then there's no traffic, so that's T bar, that's going to be half again.
oh.
Okay, it's just easier this way. And then not rainy is 2/3. And then given that it's not rainy, there will be heavy traffic with the probability 1/4. Not rainy and still traffic, the probability is 1/4. Not rainy, no traffic, T complement of T bar, that's 3/4. And then again, one more thing, she's getting late. If it's rainy, so this, and there's traffic, so this, I arrived late for work, but yes. That's half again. And then rainy, not
And then
traffic,
no traffic is the
late
other one
again.
half.
Yeah, yes.
And then
This way. Not rainy, traffic, getting late. What's the probability?
1/4.
On the other hand, the probability of being late is
Oh,
reduced to
one
1/8. And then rainy, no traffic, not late.
is
1 minus 1 over 8. That's 7 over 8.
yeah.
Yeah. Now you have all of these options, like all of
Wow.
the cases that you can find.
Okay. What is the probability that it's not rainy and there's heavy traffic? So not rainy and then traffic. And that I'm not late.
So not rainy, so 2/3. And then traffic, so T, that's 1/4. And I'm not late. So that's 7/8. Right?
Oh, not late, yeah. So 7/8% that's not all of that
Two
happens?
2/3. No, no, not the final number. Everything is happening simultaneously. So you're taking the probability of not raining, so that's 2/3 times, and then there's traffic, so that's 1/4 times, and then she's what? She's not late.
7/8. Or three.
3 for what is the what did you find this? I forgot. Probability of in other situations, rainy. Oh my God. Is the table correct? On the other hand, the probability of being late is if it's not rainy and there is no heavy traffic. There's no heavy traffic. But this should be 1/8. It says no heavy traffic. This should be 7/8. What is the other case then? In other situations where it's rainy, not traffic, no traffic. Let's see, complement. Not rainy. Oh my God. Okay. And traffic. It reduces to 1/4. That's not raining, so 2/3. And there is heavy traffic, so that's 1/4 times, and then she's not late. So that's 1/8.
Okay. So that's
Yeah, so if you get a question like this, but there's so many things happening together, it's not a probability distribution, the x isn't changing. So instead of writing all the possible cases, it's going to be a lot, just draw this diagram. And same goes with throwing a die n number of times, like 3 times. And 2 comes up on 1 and 5 comes up on 70. You need to list out all the cases, just draw the tree diagram.
mm,
Okay, and then just follow the arrows where it's going rainy, not rainy, traffic, late.
okay. What is the probability that I'm late?
Okay, so you need to consider all the cases where she does get late. So in this case, here she's getting late, so which is 1/3 and then
Times
traffic and then late. So basically skip all the L complement or the L bar parts and then find all the probabilities and then add all of them up.
that's this the first one.
Okay.
And then
Plus,
it's plus
is
this
it,
one,
is she still getting late? No.
right? So it'll be 2/3
Well, she's
times.
getting late no matter what, right? I'm just thinking, just consider all the possibilities of her getting late. If there's no traffic, she's still getting late, right? This isn't the probability of her not getting late. Rainy, traffic, she's getting late half. Rainy, not traffic, she's getting late also. Oh my God. So
Why is
basically,
she always
consider
late?
all
Is
the
she
cases.
ever on time?
So basically, consider all the cases. Maybe she's uh, hungover
It's like
last night,
100% of the time she's late.
too much makeup. I don't
She
know.
needs to get her stuff together.
But did you get the idea of what you're supposed to do?
I think, yeah.
Okay, so to draw the tree diagram. This just makes things easier.
So it'll be mm, one you do this
I'll
way.
send you the link. It has good questions on this. If you want, if you have time, you can practice on your own.
Okay.
Um, it's set on the. I can set it on the text as well if you want it.
No, I'll open it here.
It's this one.
Or yeah, will you send it over text?
Yeah, I can do that.
I'll practice some of these crazy late people.
Yeah, yeah. Also, this one has like bunch of every problem, like tree diagram or the what was the other thing? The independent thing. This one has got
Hmm.
everything. So you can practice more from here.
Does it have card problems like the ones that
Everything.
my teacher
Yes,
gave
everything.
us?
Everything. Yeah.
Rank of a rank of a rank.
Yeah. So what else do you struggle with? Like, is it you trying to figure out what you're supposed to do?
I think
Yeah.
it's usually just figuring out what I'm supposed to do.
Yeah, okay. Again, just practice like two questions from each exercise that way you will. If it's like a fixed thing, probability of picking one exact thing from a bunch of things, that's just going to be the permutation combination. Picking of you, probability of you picking at least some of the things, so there's going to be multiple cases. So 4C1, 4C2. And if it's like X variable that keeps on changing and the question is to find the probability for all of them, it's going to be the table.
Yeah.
What else you have? And you got that whole joint table thing, right? The two-way table? The
Yeah, I
mark.
understand all that.
Okay.
I
Okay.
think it's also memorizing like the
The number of cards and
for the two-way table, it's like well,
yeah,
the
you
one
need
where
depending on the
you
question, you need to figure out what the numerator and denominator is going to be given
yeah.
something has happened. So is it the whole of A or is it the satisfied plus not satisfied part? Just like that. The test is on Friday, right? Next Friday?
Next week on Thursday.
Thursday. Okay. So okay, we'll
But
practice.
it'll mirror the practice test I sent you.
Okay, I can send you more
So
questions. Depending
it'll
on
literally be those questions, but just like probably
di-
different numbers.
different. Oh, okay. So you should be able to score 100 on 100.
Yeah. Well,
Inshallah. Okay, so we'll see you on Tuesday then.
yeah.
Okay.
I'll text you if I need help with anything, but I
Yeah.
think tomorrow's lesson will probably just be more like hard questions.
Okay.
But the test won't have anything other than what he gave us.
Okay. So once you get the questions tomorrow, you can just send it to me so I can find more of them.
Okay.
Okay.
Then I'll see you on Tuesday.
Okay. Bye.
Thank you.
Yes.